November 1942. Deep in the English countryside of Hampshire, a group of scientists and engineers prepared to initiate an experiment that most observers considered absolute madness. The setting was a grass runway, shrouded in the gloom of a damp British autumn. But the mechanism they had installed was unlike anything seen in the history of aviation. Observers from the United States stood by, skeptical and perhaps a bit concerned for the sanity of their British allies, as the order was given to ignite the system. In an instant, the damp silence was shattered by a roar comparable to a hurricane mixed with the scream of massive blowtorches. Two parallel lines of pipes, stretching the length of the runway, erupted into walls of flame, reaching 15 feet into the air. The heat was instantaneous and physical, a thermal wall that punched through the cold night air. Within minutes, the impossible happened. The dense, suffocating fog that had reduced visibility to a mere 50 yards began to vanish, boiled away by the sheer violence of the heat. Visibility expanded to 200 yards, then more, creating a glowing canyon of clear air amidst the soup of the weather. The glow of the flames was visible from 20 miles away, a beacon that defied every rule of wartime blackout and concealment. The American observers were stunned. The Air Ministry was vindicated. German intelligence, observing from across the channel, would eventually be baffled by what they termed a runway edge lighting of extraordinary intensity, completely failing to grasp that the British hadn't just built a light, they had built a machine to kill the weather. This was the birth of FIDO, the Fog Investigation and Dispersal Operation, a system that would save thousands of lives by doing the exact opposite of what history often claims. There is a pervasive myth in World War II history that implies Britain used artificial fog to hide its airfields from the Luftwaffe. This title and premise contain a fundamental historical error that inverts the reality of the air war. Britain never created artificial fog to conceal its bombers. Instead, it built a system to incinerate natural fog to ensure those bombers could land. The irony of the situation is stark. It was actually Germany, the aggressor, that extensively deployed artificial fog technology for concealment, blanketing battleships, factories, and entire cities in chemically generated smoke to hide them from Allied bombing. Britain's approach was the polar opposite. They lit the night sky on fire and dared the enemy to see it. While the Germans hid in the smoke, the British burned a path through it. The story of FIDO is not just a tale of engineering. It is a story of desperation, innovation, and a fundamental strategic choice between concealment and operation. To understand why Britain was willing to turn its airfields into blazing beacons visible from the Dutch coast, one must first understand the enemy that was killing RAF crews faster than the Germans could shoot them down. By 1942, RAF Bomber Command was facing a paradox that threatened to cripple the offensive against the Third Reich. Crews who had survived the harrowing flight over Germany, dodging night fighters, flak, and were returning home only to die within sight of their own runways. The enemy was the British weather. Britain's unique geography, combined with the industrial pollution of the era, created the perfect conditions for persistent, lethal fog. The coal smoke from millions of domestic fires mixed with the natural moisture of the island air to produce dense, yellowish smogs that could linger for days. In East Anglia and Lincolnshire, the heartland of the bomber war, these fogs would roll in with little warning, blanketing airfields in an impenetrable white sheet. Returning Lancaster and Halifax bombers, low on fuel and often damaged from combat, would find their home bases vanished. Pilots would circle desperately, praying for a break in the cloud, until their fuel gauges hit empty. Some crews, having survived the hell of the Ruhr Valley, were forced to bail out over the English countryside. Others attempted blind instrument approaches, crashing into the ground, or obstacles they couldn't see. The casualty rates from weather-related accidents were becoming unsustainable. Historian John Terrain noted that the weather was Bomber Command's first and everlasting enemy. It was a silent killer, claiming trained navigators, pilots, and gunners who took months to train and were impossible to replace quickly. The situation was so dire that Winston Churchill himself intervened. In September 1941, receiving reports on the scale of the crisis, Churchill issued a personal directive to Geoffrey Lloyd, the Secretary for Petroleum. His note, signed simply WSC, was characteristically blunt and tolerated no excuses. It is of the greatest importance to find a means to dissipate fog at aerodromes so that aircraft can land safely. Let full experiments to this end be put in hand by the Petroleum Warfare Department with all expedition. The mandate given to the Petroleum Warfare Department was technically impossible. By PISIM standards, they needed to clear fog from active military runways quickly enough to catch a landing bomber, cheaply enough to be feasible, and reliably enough to bet human lives on the result. The solution they developed abandoned all notions of elegance or economy in favor of brute force thermodynamics. Professor David Brunt of Imperial College London provided the theoretical math. If you could raise the temperature of the air by approximately 5 degrees Fahrenheit, the water droplets comprising the fog would evaporate. The problem was how to heat millions of cubic feet of open air on a windy runway. The answer, led by Sir Donald Banks and Chief Engineer Arthur Hartley, was to burn fuel on a scale that would make a frantic logistical officer weep. They designed a system of 2 parallel steel pipelines running the full length of the runway, typically 2,000 to 3,000 yards long. These pipes were perforated with burner jets at regular intervals and fed by massive pumps connected to fuel reservoirs. When ignited, the system didn't just flicker, it roared. A standard installation consumed approximately 100,000 imperial gallons of petrol per hour. That is the equivalent of 67 gallons of fuel burning every single second. At the larger emergency landing grounds like RAF Woodbridge, consumption could exceed 200,000 gallons an hour. The immense heat generated by these walls of flame created a thermal updraft that literally punched a hole through the fog, clearing a visual tunnel for the pilots. The experience of landing effectively inside a fire was a psychological assault on the senses of the air crews. Pilots are trained from their first day of flight school that fire is the ultimate enemy. A fire on an aircraft is a death sentence. A fire on the ground usually indicates a crash. To ask a pilot, already exhausted from a 10-hour mission and likely nursing a damaged aircraft, to deliberately fly his plane between 2 raging walls of flame required a massive suppression of survival instincts. Air Vice Marshal Don Bennett, commander of the elite Pathfinder Force, made the first test flight in February 1943. He described the surreal experience as having vague thoughts of seeing lions jumping through a hoop of flames at the circus for the young crews of Bomber Command. The experience was visceral. Flight Lieutenant Douglas Hay described seeing the glow from 30 miles away. As they got closer, the individual jets became distinguishable, and at 1 mile out, the roar of the burning fuel could be heard over the sound of the aircraft's own engines. On final approach, the heat radiating through the cockpit windows was intense enough that crews instinctively leaned away from the flames, even though they were safely in the center of the runway. The sensory overload was dangerous. The flickering light and heat shimmer could distort depth perception, tempting pilots to fly visually rather than trusting their instruments. Yet, once they were down, the relief was overwhelming. They had cheated death, finding a warm, glowing corridor home in a world of cold gray blindness. On the ground, the operation of Fido was a masterpiece of dangerous choreography. The ground crews at stations like RAF Fiskerton or RAF Gravely lived with the system and its temperamental nature. Activation orders would come from flying control about 45 minutes before the bombers were due. The men would rush to the fuel tanks, opening valves that released thousands of gallons of low-grade petrol into the runway pipes. Ignition was not a remote-controlled affair in the early days. It was manual and terrifying. At some stations, brave souls on bicycles with flaming torches would ride alongside the pipes, lighting the jets. At others, a jeep towing a flaming brand on a long pole would race down the runway, the driver looking straight ahead while the igniter in the back ensured the fuel caught fire. The noise was deafening, requiring the crews to wear improvised ear protection made of beeswax and cotton wool. To communicate, they had to scream directly into each other's ears. The heat was so intense that grass was scorched to bare earth for yards around the pipes, and vehicles parked too close would have their paint blistered and tires melted. On summer days, the heat from a test burn could soften the asphalt of the runway itself. It was a hellish environment, yet the ground crews took immense pride in it, knowing that every time they lit the fires, they were bringing the boys home. While the British were burning the sky to create visibility, the Germans were using chemistry to destroy it. This contrast is critical to understanding the different strategic realities of the two nations. Germany, being on the receiving end of the strategic bombing campaign, needed to hide its static assets. They developed the Nebelgert smoke generators, which used chlorosulfonic acid and sulfur trioxide to create dense, artificial white fog. When this acid mixture came into contact with the moisture in the air, it reacted to form a cloud of hydrochloric and sulfuric acid droplets. It was effective, but it was nasty stuff. It would sting the skin, rot clothing, and strip the leaves off trees. The battleship Tirpitz, hiding in the Norwegian fjord, was protected by such extensive smoke screens that dendrochronologists today can still see the stunted growth rings in the nearby pine trees from the year 1945. The acid fog literally stopped the forest from growing, but there was a limitation to the German approach. You cannot operate an airfield effectively under a smoke screen. If you hide the airfield, you also hide the runway from your own pilots. The Germans prioritized defensive battleships and factories, accepting that operations might halt. The British, desperate to keep the pressure on the Reich, prioritized offense. They chose to reveal their airfields to the entire world if it meant their bombers could fly. The operational impact of Fido became undeniable as the system spread to 15 key airfields across eastern England. The most dramatic validation of the system came during the Battle of the Bulge in December 1944, as von Rundstedt launched his massive armored offensive through the Ardennes. He did so under the cover of arguably the worst weather in European history. A massive fog bank grounded the Allied tactical air forces, allowing German panzers to smash through American lines without fear of the dreaded Typhoon and Thunderbolt fighter bomb. For days, the Allies were blind, but back in England, the Fido systems were burning around the clock. Bomber Command, utilizing the corridors of fire, was able to launch and recover heavy bombers despite the fog, maintaining a relentless pressure on German supply lines and infrastructure that the tactical air forces could not. RAF museum records state that the halting of the Ardennes offensive was due in large part to the weight of Allied air attack that was only possible because bombers could take off and land with Fido. During this period, the fuel consumption was staggering, draining national reserves, but the strategic value of keeping the heavy bombers flying, when the rest of the Air Force was grounded, was incalculable. Specific incidents highlight the miraculous nature of the system. On a night in February 1944, a Lancaster from 101 Squadron, piloted by Sergeant R. Dixon, limped back to England. The aircraft had been mauled by a Messerschmitt 110 night fighter in flak. The hydraulics were shot, the landing gear was useless, and fuel was streaming from ruptured tanks. In normal conditions, the crew would have been forced to bail out, losing the aircraft, but RAF Luftwaffe activated. Fido Dixon brought the massive bomber in for a belly landing directly onto the illuminated runway. As the metal hull scraped along the concrete, sparking furiously, the incendiary bombs still trapped in the bay ignited. The bomber slid through the Fido flames, a burning wreck inside a corridor of fire, yet, because they could see exactly where they were, Dixon kept it on the runway. The aircraft came to a halt, and all 7 crew members scrambled out alive before the plane was consumed. Without the visual reference of the Fido flames, that crash landing in the fog would have almost certainly resulted in a cartwheel into the mud and total loss of life. Conversely, the tragedy of the night of the fog in December 1943 showed the cost of absence. With fog blanketing the entire island, crews attempting to reach non-Fido stations crashed in droves. One Lancaster crew, led by squadron leader Ernest de, ran out of fuel just 5 miles short of the Gravely Fido installation, dying agonizingly close to safety. The economics of Fido were a subject of fierce debate in the halls of power, but the grim arithmetic of war always favored the system. By the end of the war, FIDO had consumed over 30 million gallons of fuel. The cost of a single hour of operation at a large runway was estimated at $200,000 in 1940s currency. Critics in Parliament asked if this fuel wouldn't be better used for tanks or trucks. The Air Ministry's response was cold and pragmatic. A heavy bomber cost nearly £60,000, but the 7 men inside were priceless. It took 18 months to train a pilot, a navigator, and a bomb aimer. To lose a seasoned crew to fog was a strategic disaster. The ministry calculated that if Fido saved just 1 bomber for every 10 times it was used, it paid for itself financially. If it saved the lives of the crew, the moral and strategic value is infinite. The psychological impact on the bomber force was perhaps the greatest return on investment. Crews, knowing that Fido diversionary airfields were available, flew with less anxiety. They didn't have to hold back fuel for a desperate search for a clear patch of sky. They could press on to the target, use their reserves, and know that even if England was socked in, the burners would be waiting. The sheer visibility of the system remains one of the war's great ironies. German pilots and observers on the Dutch coast, just 60 miles across the North Sea, could clearly see the glow of Fido installations burning like miniature suns on the horizon. The Luftwaffe intelligence services mapped these locations. They knew exactly where the British airfields were, and yet, this visibility never translated into effective countermeasures. By the time FIDO was fully operational in late 1943 and 1944, the Luftwaffe's offensive power over Britain had been broken. They didn't have the bombers to attack these lighted targets, and their intruder operations were sporadic. Furthermore, German intelligence fundamentally misunderstood what they were seeing. Captured documents reveal that German analysts believed the systems were some form of experimental runway lighting, or perhaps a psychological warfare tactic to show off British fuel reserves. They couldn't conceive that the British would burn 100,000 gallons of fuel just to clear fog. They assumed it was a trap or a heavily defended decoy. In a way, the sheer audacity of the waste protected the system. The Germans thought, surely they wouldn't do that just for fog, and so they looked for a more complex, a sinister explanation that didn't exist. The legacy of Fido is preserved in the few surviving strips of rusted pipe at places like RAF Metheringham, and in the archives of the Imperial War Museum. It was a technology born of specific wartime necessity where cost was irrelevant, and survival was everything. After the war, the system was briefly considered for civilian airports like Heathrow. Pipelines were even laid, but the economics of peace killed Fido quickly. No commercial airline could justify the cost of burning that much fuel to land a passenger plane. They would simply divert or wait. The Clean Air Act of 1956 removed the coal smoke that caused the super-dense fogs, and the invention of electronic instrument landing systems (ILS) eventually made blind landings routine. Fido became a dinosaur, a creature of a specific, violent epoch. But for the 10,000 to 15,000 airmen who owed their lives to it, it was no dinosaur. It was a miracle. Ultimately, the story of Fido challenges our understanding of military engineering. We often look for the superweapon, the secret radar, the jet engine, the atomic bomb. But Fido was not hype. It was low-tech applied on a gargantuan scale. It was a triumph of plumbing and pyrotechnics. It proved that sometimes the solution to a complex problem like meteorological interference isn't a subtle scientific tweak. Sometimes, the solution is to simply apply more energy than the weather can withstand. Britain didn't hide from the fog. They didn't fly around it. They grabbed the problem by the throat and burned it out of the sky. The title of the video that sparked this discussion claimed Britain created artificial fog. The truth is far more compelling. In a world of shadows, camouflage and blackouts, the British dared to light the biggest fires in Europe, turning their vulnerabilities into victory. They turned the darkest nights of the war into day, and in doing so, they brought the boys home.